This video will aim to give an introduction to factorising basic algebraic expressions. Students should already have a good understanding of general algebraic terms and have some familiarity with the process of expanding expressions. To begin with, we will review how to expand an expression. To expand an expression containing brackets, we need to multiply what is outside the brackets by everything inside the brackets. Here is an example of expanding an expression that contains numbers and letters, or as we will call them, pronumerals. We need to multiply the 2 by everything inside the brackets. This is because a multiplication sign is always implied between a term or number and a set of brackets. So the 2 is multiplied by the 4a to give us 8a, and the 2 is multiplied by the m to give us 2m. So this is the expanded form of this expression over here. So hopefully we all remember and have a good understanding of how to expand simple algebraic expressions. Now we will move on to factorising. Factorising can be thought of as the reverse of expanding. When expanding, we take the brackets out of an expression, but when we factorise, we aim to put brackets into the expression. To do this, we need to take a common factor out of the expression and put brackets around what is left. Here is a basic example with pronumerals. When we write it out like this with the multiplication signs, we can see that there is an a on both sides of the addition sign. Therefore, it is a common factor. So we can take it out and put what is left, the b, the addition sign, and the c, in brackets. When it is written like this, we know that the a will still be multiplied by the b and the c as by the rules of expanding. So this is the factorised form of this expression here. But why would you want to factorise an expression, you might ask? Well, it gives us the ability to change expressions from an expanded form, so it is a way of manipulating expressions or equations. This will be useful for later maths and solving equations. Factorising also allows us to write the expression in a more condensed or simplified form. Okay, so there will be a few steps here, but once we've had some practice, you do not always need to write out each of these steps. We will use the expression that we expanded previously, 8a plus 2m. The first thing we need to do is find the factors of each of the terms. The terms in an equation are separated by a plus or a minus sign. This expression has two terms, here and here. The factors of 8a are listed here. These are the numbers that can be multiplied to produce 8a, or the numbers which divide evenly into 8a. And the factors of 2m are listed here. Now we need to identify the common factors. These are the numbers and or pronumerals which are factors of both terms. In this case, the 1 and the 2 are common factors. When we are factorising, we need to take the highest common factor. I'll explain why in a moment. And also, taking 1 would not be a good idea, as multiplying by 1 will not change our expression. As we can see here, the highest common factor is 2. Often you will not have to write out all the factors, as you can simply think about the factors and find the highest common one. Now, we will use this common factor to write the expression using the factors for each term. So, in this example, we write 8a as 2 times 4a, as 2 is our common factor, and we need to multiply that by 4a to get 8a. We then have the addition sign from our original expression, and then we write 2m as 2 times m, again 2 being our common factor, and m being what we need to multiply it by to get 2m. For the next step, I've just written this down here so we can see. And we can see that 2 is on both sides of the addition sign, and it is our common factor. So we can take it out and put what is left in brackets. That is the 4a, the plus, and the m. This means that 2 will still be multiplied by both the terms, but we only need to write it once. This also shows why you need a common factor, as it must be able to be multiplied by both of these terms inside the brackets to give us our original expression. Now, I said I would explain why we had to use the highest common factor. and I will use this example to show you. So first, we need to identify the factors of these terms. In this example, we can just write the factors of the numbers because we know that a common factor will not contain an a because there is no a on this side of the expression, and it will not contain a b because there is no b on this side of the expression, so it cannot be common. This means that our common factor will just be a number, but the other factors we pair with it later to create these must have a pronumeral. For example, if our common factor were 2, we would have to multiply 2 by 3a to give us 6a. To see why it is important to use the highest common factor, let's try using 3 as our common factor even though 6 would be the highest. Let's take 3 as a common factor and write our expression using 3 and the required factors. So 3 times 2a gives us 6a, plus 3 times 4b will give us 12b. So we can now take the 3 out as a common factor and put what is left over in brackets. But when we look at this, we can see that there is still a common factor left within the brackets. We could take 2 as a common factor of 2a and 4b. So this expression here could be factorised again. But if we use 6 as our highest common factor, this would not be the case, as I will do. So here we take the same expression and use 6 as our common factor. We write out the expression using the required factors. As we can see here, 6 times a gives 6a, 6 times 2b gives 12b. Now we can see, once we take the common factor out and put the rest in brackets, that this cannot be simplified, cannot be factorised any further as there is no common factor of a and 2b. Another thing we can do is to use our knowledge of expanding to check that we've factorised correctly. We simply take our factorised expression and expand it to see that what we get is the same as the expression we started with. If I've made a mistake, we will end up with a different expression. So in this case, 6 times a plus 6 times 2b gives us 6a and 12b, which is what we started with, so we know that it is correct. Here is another example of factorising. In this example, the common factor will be a number and a pronumeral, but it is treated exactly the same. We could just take the factors of 18 and 12 and then take a common factor of the pronumerals, or we can think of the factors of 18a squared and 12ab. Either way, when we write them down, we will find that 6a is the highest common factor, as 6 is a factor of both 18 and 12, and a is a factor of both a and a squared. 6a is also a factor of 18a squared and 12ab. It does not matter which way you think about this, as long as you end up with the highest common factor and all of the common pronumerals. We also need to remember that a squared is a times a, so both the factors of 18a squared will need to contain an a. Once we have written it out, we can take the highest common factor and put what is left in the brackets. So 6a times 3a gives us 18a squared, and 6a times 2b gives us 12ab. And they are taken like that. The lines here indicate where each term is going. Remember that we only need to write the common factor once outside the brackets, because the brackets mean that what is outside them is multiplied by both terms inside. So we know that the 6a will be being multiplied by the 3a and the 2b. So you can see that this process is really the same as before. Sometimes you take out only pronumerals as factors, but again the process is the same. Let's take this example here of 2a squared plus ab squared. You can see that the only numbers we have here are the indices, but they are indices of different pronumerals, so they cannot be common, as this is a times a and this is b times b. Let's look at the common factors for the pronumerals in this equation. So here they are. As we can see, there is a common factor of a, as it is a factor of a squared and a, and these are on different sides of the addition sign. 1 is also a common factor, but as we discussed earlier, 1 is not a useful factor because it will not change our expression. So we use the common factor of a and write out our expression, remembering that a squared is a times a is a times 1, and b is b times b. You'll see that I've written a as a times 1, but we know that multiplying by 1 will not change it, so it is not really necessary to write it. We can now take one factor of a out of each side, but only one because on the second side there is only one, a. This leaves us with 1a left on this side, which goes into the brackets. We don't need to write the 1, and we put the b and the b times b as b squared. That is all I have time for. The next lesson would cover how to factorise with negative numbers and move on to factorising polynomials and quadratics.